So now we're going to take everything that we know and put it all together so that we can graph. You may remember from last year, the first thing we're going to do is factor. So nothing I can do in the numerator, but the denominator has a GCF of 2, so I'll take that out. And nothing cancels, so that means I don't have any removable discontinuities. So down in my table, I'm going to cross that off. I don't need to worry about that. So my domain restrictions come from when the denominator equals 0. So 2x plus 6 can't be 0, which means x can't be negative 3. So my domain would be negative infinity to negative 3 union negative 3 to positive infinity. Now let's look at our horizontal asymptotes or in behavior. So I like to look at my original for this one, not the factored one. In my original, I see easily that my degree of the numerator is 1, degree of the denominator is 1, so that means that the horizontal asymptote is the ratio of their leading coefficient, so 1 over 2. Make sure you have that y equals. What we're going to add now is we're going to see, does our function cross our horizontal asymptote? So what we do there is we take our horizontal asymptote and we set it equal to our original function. It's easier to do this in the original versus the factored form. So once again, what we're doing is saying our horizontal asymptote equals our function. Does this ever cross? And now we're going to cross multiply. So I would do 1 times 2x plus 6 equals 2 times x minus 1. So I get 2x plus 6 equals 2x minus 2. And you may notice that my x terms are going to cancel. So I get 6 equals negative 2. Well, 6 does not equal negative 2, so this means it does not cross. When I get my x's all cancel out. So now let's look at an x-intercept. An x-intercept means y equals 0. So when I set my original equation equal to 0, or really we could do the factored equation, but this one is kind of boring. When I cross multiply, what happens to this denominator? I get 0 times 2x plus 6 equals x minus 1. So this whole left side becomes 0. This is where I say, let's just set our numerator equal to 0, because whenever I cross multiply, the denominator goes away. I solve and I get x equals 1, write it as a point. So 1, 0. A y-intercept means that x equals 0. So I'm going to plug that in either equation. So y equals 0 minus 1 over 2 times 0 plus 6. So y equals negative 1 over 6. Intercept should be written as a point, so my y-intercept is 0, negative 1 over 6. Vertical asymptotes are, after we take out wholes, what's left in the denominator. So 2 times x plus 3 equals 0. So x plus 3 equals 0. X equals negative 3. You need this as an equation, so x equals negative 3. Now we're going to do a sign chart. On our sign chart, we put vertical asymptotes and x-intercepts. Vertical asymptotes and x-intercepts. So that means on this sign chart, I'm going to have negative 3 and positive 1. And then I'm going to put my fraction. So x minus 1, 2x plus 6. Alternatively, I could plug it into the entire thing and see if I'm getting positives and negatives out, but I prefer this way. Okay. You're going to see that our rationals start getting really big. So I'm going to use my shortcut. So if I'm looking at x minus 1, that changes from positive to negative at the critical value of 1. So it's left, to the left it's negative, to the right it's positive. Now if I look at 2x plus 6, that has a critical value of negative 3. It's negative to the left of negative 3 and positive to the right. And now I am dividing, which has the same properties as multiplying. A negative divided by a negative is a positive. Negative divided by a positive is a negative. And a positive divided by a positive is a positive. So that means we are positive to the left of -3, negative between -3 and 1, and positive after 1. And remember, when we say positive, what we're saying is we're above the x-axis. Okay. So what we're going to do is do an analysis of this. So the -3 was a vertical asymptote, and this was an x-intercept. So remember in the first unit, we did vertical asymptote analysis. So if I want to do that here, the limit as x approaches -3 from the left of my function, what kind of numbers do I have? To the left of -3, I have positive, so that's going to go to positive infinity. The limit as x approaches -3 from the right, what's to the right of my vertical asymptote is negative, so negative infinity. This is going to help me sketch my graph. So on my graph, the first thing I do is my horizontal asymptote and my vertical asymptote. So I have 1/2, just need to go back and look at that, 1/2 for my horizontal. I have -3 for my vertical. Let's add some points. So I have an x-intercept at 1, 0, y-intercept at -1/6. And next we're going to add some guiding arrows based on our vertical asymptote analysis. So to the left of -3, it's going to positive infinity. So I'm going to draw a little arrow going up. To the right of -3, it's going down. Okay, now let's look at our sign chart. So everything is positive to the left of -3. So I know I have this arrow. And I'm not crossing my my horizontal asymptote. I'm not crossing that. So we're just going to flatten out there. Now, I know that between -3 and 1, so -3 of my x-intercept is negative, and then we're not going to cross our horizontal asymptote. That's why we check that. So I'm just going to get really close to it.